The area function gives a net area of the region bounded by the graph of f and the t-axis on the interval a to x. So here's a visual of what a of x looks like. Now if we added on some little distance h, we can find the area of x plus h. Now subtracting these two areas, we're left with this little one. We can approximate this using the length of h and the height of f of x. So here we have the difference between these two areas is approximated by h times f of x. First we can divide by h, and then we can take the limit as h approaches 0 in order to make this much more accurate. Notice on the left-hand side we have the definition of a derivative. So this means the area function of f is an antiderivative of f on a to b. Now remember, when we take the antiderivative, we do have a constant of integration. So here if we do f of b minus f of a, we have to replace our x values as b and a. Now remember, the area function of a is just going to be a single point, right? And so this area is going to be equal to 0. Now the area function of b is going to be this area right here. So when we plug this in, we get a of b plus c minus 0 minus c. So the constant of integration cancels out, and we're just left with the integral from a to b of f of t dt. And this leaves us with our theorem. If f is continuous on a to b, and capital F is any antiderivative of f on a to b, then we have the integral of a to b of f of x dx is equal to capital F of b minus capital F of a.